Good morning all. My name is Sreekanth and I am going to discuss about the data acquisition system in Labview. So data acquisition, actually what data acquisition means, it is a conversion of physical parameters to digital parameters. So always it will be converting the physical world into digital world. So while telling about data acquisition, most of the data acquisition system is a challenging task. Almost all the acquisition system is very challenging and control and transfer is easy. So here we are going to discuss about the data acquisition system which is present in Labview. So normally data acquisition system block will be having sensors for measuring the analog values, and then it will be having signal conditioning circuit. So what this signal conditioning circuit will do, it will amplify or it will filter the signals which are coming from the sensors, and eventually it will be giving to A to D conversion. So this block will be converting the analog signals into digital form and which can be fed into system. Why we are going for Labview means, so while telling about Labview is having a good data acquisition system. So it is having a hardware called DAC. DAC can acquire analog signals and it can be converted into digital and it can be given to system which is having a Labview software. So that DAC system is having that capacity of conversion of analog signals into digital, and it can acquire the data very quickly, it can generate the signal for measurement, and it can control and it can be given to external world. So we are going for Labview for data acquisition system mostly. That DAC system, the capacity of DAC system gives easy conversion of digital analog signals to digital form, and the DAC system consists of signal conditioning circuit, ADC, and a computer bus. Computer bus is used for getting the values in the system which is having the Labview software. So this is a typical diagram for data acquisition in Labview. So here we are connecting some sensors in the data acquisition hardware. So this hardware can be directly connected to system which is having the Labview software. So this hardware is having so many pins, and it is having a signal conditioning block, and it is having a to D conversion unit. So whatever sensors we are connecting here, it will be taking to DAC system, and the conversion and all the filtering process will be done, and it will be given to system which is having Labview. So in the system we can go for representing that data into graph or even control panel indicators. Whatever indicators which are present in Labview we can use for representing these data which is coming from the DAC unit. So here digital signals are also given. So DAC is having that specialty, it can take analog as well as the digital value, and it can give the output as analog and as well as in digital form. So these are all some of the sensors which can be connected in the DAC system. So sensors, thermocouple and thermistor, which is used for sensing the temperature, photo sensor, which is used for sensing light, microphone for sound parameters and all, strain gauge for force and pressure, then a potentiometer which is used for getting the position and displacement of some object, then accelerometer for getting the acceleration, and pH electrode for pH. Actually these are some of the sensors. There are a lot of sensors which can be interfaced with DAC unit. Here I am mentioning some of the sensors only. So all these sensors will be giving analog, sometimes it may be giving analog values, or sometimes it may be giving digital values. So whatever these sensors will be given, according to that we can configure the DAC and we can get the values in the DAC, and finally we can give the values coming in DAC to the Labview software installed system. So DAC interface. So DAC is actually interface between the physical parameter and a computer system. So DAC will be having the input, especially analog input and digital input, and analog output and digital output. So it can take digital input and it can give analog output. It can take digital input and it can give digital output. Also it can take analog input and give analog output, and analog input and digital output. So almost all the things can be done using the DAC device. The three components of DAC device are signal conditioning circuit, analog to digital conversion unit, and computer bus, which is used for connecting to computer system. So signal conditioning circuit, actually it will be consisting of amplification, filtering and isolation circuit. So whatever the analog value which is getting from sensor, it will be having some noises, and it will be a small analog variation. So what we will do means, we will amplify these signals and we will filter for removing all the noises. So that is done by signal conditioning circuit. So normally it will be consist of amplifier, filters and isolation circuit. Then that signal is given to ADC. So there analog to digital converter will convert the analog values which is coming from the signal conditioning circuit to digital, and there we can give the options for how much rate it should be sampled, and all these things we can directly give from Labview itself. We can directly give. I will show how to give all these things. So these samples are transferred to computer through the computer bus which is present in DAC system, and in the computer, by using the Labview software, we can get these values and we can reconstruct the data. Reconstruct means we can display or analyze. Display can be done using graph or any indicator we can use which is present in Labview. So DAC, actually this DAC is given by National Instruments, so they will be providing the drivers for DAC. So normally drivers for DAC are unique. If you are going for DAC means you have to use a National Instrument, the product which are given by National Instruments. Otherwise we have to get the drivers which can be opted for some other devices. So normally National Instruments provide the drivers for DAC system, so that we can go directly to National Instruments DAC system itself. So this is the data acquisition palette which is present in Labview software. So till now I explained about how the hardware and what will be the hardwares and all. So now I am going into the software section. So this is the data acquisition palette which is present in measurement IO, which we will be getting from the block diagram panel. So from the block diagram panel we can get measurement IO, and in that DAC MX data acquisition palette is there. So in this palette we are going to discuss about this data assist system, this one. So this is used for getting the data, analog data, and the conversion and analysis. This block is used for that purpose. So DAC assist, while telling about DAC assist, we can get it from measurement. I already told that measurement IO and a DAC MX data acquisition system. From that we can get that DAC assist system. So it is having ADC and DAC. We can give analog signals and convert it into digital signals, and we can give digital signals and convert it into analog also. So this can be done by DAC assist system. So it will be having analog input as well as analog output, and digital input as well as digital output. So this is the way to configure that DAC assist system. So if we are dragging the DAC assist system into that the block diagram, we will be getting this option. So in that we can select according to our application. We can select analog input, analog output, counter input, counter output, digital IO. If we are giving analog input means we can go for analog input. If we need analog output means we can go for this. Digital input output also we can get from this one. So here, according to our application, we have to select which option we need. So if we are going for analog input selection, there it will give the options for voltage, temperature, then current. Like that, it will be giving so many options for measurement. So directly we can take that option and we can measure the values. And after this section, we will be going for channel selection. So it will be looking like this. So in channel selection, what we will do means we will be selecting the ADC channel which we are using. We are having so many ADC channels. Analog input 0 is there, analog input 1, 2, like that. Each devices will be having a different number of channels. So we can select which channel we are going to use, and here itself we can select number of samples we have to take within a particular time. We have how many number of samples we have to take. All those things we can set in this section. If we are going for analog output means, there also we can select which channel we have to get the analog output. Since it is here it is shown as analog input, we are getting a I naught. If we are going for analog output means we will be getting a O naught, a O1, like that we will be getting. And whatever the parameters we are going to measure, we can directly give it here: voltage, current, temperature, whatever we are going to give, we can directly give it, and we can implement it directly from here itself. So what is the main thing is that there is no need of knowledge about these reference voltages, and nothing like that is not needed, because it is a purely graphical programming, so there is no need of that kinds of thing. After initializing all these things, we will be getting a DAC assist unit like this. So here the data is coming out. Actually it is configured as analog output. So if we are configuring it as analog input, then data will be giving from this area. So according to our settings, the DAC assist system will be having a different function palette. Means it will be showing different function block according to our settings, and it is having that error in and error out method for determining the error signals and all, and we can give the timeout signals also. So this is the overall configuration of DAC assist system. So once again I can tell, we will be getting DAC assist system from measurement IO, and if we are taking the DAC assist system, we will be getting an option like this. So in this we have to select the which parameter we are going to measure. So we can give analog input, analog output, or digital input output. Whatever we are going to do, we can give it here. So if we are going for analog input means, there also we will be having voltage, temperature, current, like that it will be having. So whatever parameter we are going to measure, we can directly give which parameter we are going to measure, and after that we can go for the channel selection, which channel we are going to select. After all these things, we will be directly getting the DAC assist system. So whatever the channel we have selected here, in this channel we will be connecting the sensors. If we are taken analog input means, we will be connecting the sensors in this channel, and this DAC assist system will be placed in Labview, and directly by running the Labview application we can get the values in DAC assist system in the Labview, and from DAC assist system in Labview we can give it to indicators, so that we can view what are the values which are coming. And finally I will be telling about some product which National Instruments provide for data acquisition. So normally they will be providing two types, one is single device, and next one is a system. So the single device system are used for basic data acquisition system, which there is they won't give much accuracy, and they won't give much speed of data acquisition. So normally the system will be going for the simple data acquisition system, but this one NI compact DAC and PXI platform, here these two we are going for normally high rate data acquisition system, and We are going for whenever we are going for real-time acquisition, we will be going for this NI DAC, compact DAC and PXI platform, and which is having a specialty of working in standalone mode also. So if we need basic data acquisition, we can go for this one, simple portable DAC and desktop DAC. And if we need a real-time acquisition, means we can go for compact and PXI platforms. So these are the hardwares which we are using in data acquisition in Labview, and drivers for all these things will be provided by Labview itself. We can directly get the driver, and we can directly install the driver in our system, and we can directly access the data acquisition unit, our DAC system in the Labview. So these are the products which are offered by the Labview, which are data provided by National Instruments for data acquisition system. So I hope this video will be giving the idea about how the data acquisition system is working in Labview, and what are the features we can get in Labview software for acquiring data. Thank you.